Good.
Good morning, students. We are going to find the focal length of concave mirror by read different values of V, means distance of image from mirror, for different values of U, means distance of object from all of the mirror. So it is our aim to find the value of V for different values of U and to find the focal length of concave mirror. Apparatus optical bench. When we will perform the experiment, I will told you about optical bench. 3 uprights. These are the uprights, and we can say holders which hold the pin of the mirror. Concave mirror. This is our concave mirror. One side is reflecting, and at bulge part here is the paint. 2 needles. These are the needles or pin, and meter scale. This is our meter scale if required. Now, formula. We use this formula to find the focal length of mirror. 1 by f equal 1 by v plus 1 by u. During the experiment, we will put mirror and here is object. So reading will be taken opposite to the incident ray. That is why u and v both will be taken with negative sign. During this experiment, observations, table for u and v. First we will set our mirror in a upright. Then in second upright we set object pin, and finally when there is requirement we set in third upright a image pin. The position of mirror will be denoted by P in centimeter and position of object O, position of image I. So the distance between P and O is U. This is U. And for example, position of mirror is 50 and position of object is 35. So their difference is 15 centimeter. Will be taken with negative sign. U equals PO. P and O. Similarly, distance of image pin from pole of the mirror will be considered as V. This is U and this is V, Pi. P 50 and position of image, suppose it is 20. So difference is 50 minus 20 is equal to 30 and with negative sign again. Then by using this formula, F will be equals UV upon U plus V in centimeter. As you can see here, calculations, we will take 2 or 3 reading and then we will take the average of all and we will write here our result. As you can see here on board, F equal minus, why minus? Because focal length of this mirror is always will be negative. The distance between pole and focus is called focal length, and because it is measured pole to focus means opposite direction to the incident ray, so is negative. So focal length is negative. Now ray diagram, it is mirror, concave mirror, and it is the pole. This is the principal axis. Principal axis, and this is focus. This distance is focal length, pole to focus point, and it is our 2f, or say center of curvature C. C is always equal to 2f. Center of curvature. The object is placed between focus and center of curvature, so that image will form between center of curvature and infinity. If object is very close to the focus, then image will form at a very distance apart. Our optical bench are not have too much length. That is why we always try to keep the object near to the center of curvature, so that we have easily form image. Now we will perform the experiment. Students, you must be aware about it that always mirror should be placed on soft paper or sponge, and it must be kept in this manner, so that polish or paint be safe. Now we will put this in stand. Mirror is fixed in upright. It is fixed in upright. We can adjust the height by using this screw up and down. With the help of this screw, we can adjust the height. Then in second upright, we will fix the pin or needle. Now we will, with the help of this screw, we can shift our pin left and right, and in this manner we can move it forth and back, and we will form the image of this object in this mirror in such a way so that both will move in same direction and there is no lateral displacement. First we will put it near to the mirror and we will see that in mirror, yes, here is the thick and virtual image. Now it is inverted and real image. I got here in the mirror, and here is the lateral displacement. So with the help of this screw we can remove lateral displacement, and with the help of this screw we can remove or adjust vertical displacement. If there is parallax, we can remove it. And we'll adjust now. As you can see through camera, there is a sharp image of object in mirror which is moving with this sharp image is moving with pin. Yes, now it is clear. As you can see here, this is our pin, and here white, this is image in the mirror. This is the image in the mirror which is moving with object. Now we will read the position of mirror. It is 50, and position of object pin, it is 30. Now we will move this some forward because it is at center of curvature at present. Now we will move it some forward, and it is at 35 now. It is at 35 marks. As you can see here that it is on 35. The center mark of upright or holder is at 35 and center mark of mirror is at 50. Now in another pin holder we will take second pin and will adjust in such a manner in looking the mirror, so that by moving this image pin forth and back, so that sharp image of this pin be at this image pin. We will move this forth and back, left and right, to remove the parallax, so that image of this object pin is made at image pin. Now it is clear the image is forming and there is no parallax. Thus we will read the position of image pin, and it is, as you can see here, the center mark of image pin is at 20, object pin at 35 and mirror at 50, and this is the adjustment as you can see here. This is the adjustment. By adjusting all, we can take the reading of U and V, and the same is repeated for next reading. And with the help of formula we will fill the reading here. Position of image, this is position of object and position of mirror, and the distance between P and I is V, distance between mirror and object is U here, and with the help of these we can calculate easily. By using this formula we can calculate focal length. This is f1, say. Similarly we will take another reading by changing the position of mirror, object pin and image pin. We will find f2, similarly f3, and by taking the average we can calculate focal length of concave mirror, and this is the ray diagram. First, the object is kept near to the mirror and will move far away. When it will be at 2f, center of curvature, the image of this object will form over it. Then we will move it towards some distance towards mirror, and then the image of this object will be formed at the second pin called image pin. In this manner, as you can see here, as I told you earlier, by taking reading you can easily calculate the focal length of given mirror. Thank you.